in finishing up lesson 9.1 here, we are going to look at simplifying complex fractions. Complex fraction, here's the definition of it, is a rational expression whose numerator and or the denominator contains a rational expression. Okay, so here's some examples. So this is like a over 5, so there's an algebraic fraction on top, divided by 3b, and that could be written as 3b over 1, so we'd have a fraction divided by a fraction. If you look at the next example, it's 3 over t, and we're dividing by t plus 5. Well, t plus 5 can be made a fraction by putting it over 1, so it's a fraction divided by a fraction. Here, you already have a fraction on top, divided by a fraction on the bottom. Okay, this one, we actually have two terms on top. One's already a fraction, one's not. What we'd have to do is, and we'll look at some examples like this, is get them into one fraction on top by finding common denominators, and then use our rule of fraction divided by a fraction. Okay, so you're going to use all your rules here, and we'll look at an example, but that's basically what a complex fraction is. It's a fraction of fractions. All right, so simplify a complex fraction. Notice I have a fraction on top, and I have a fraction on the bottom. It's a fraction divided by a fraction. I want to take this, and I want to multiply by the reciprocal, because that was the rule we just looked at earlier. It's just 2y minus 3x all over x cubed. So that's the first thing you see when you, because it's a division problem. So now I'm looking at what I have right here. Okay, we kind of multiplied by the reciprocal of that. All right, now I want to see if I can factor anything. So I'm going to make one big fraction. So on top, I'm going to have the x squared from this, and then I got to multiply it times 2y minus 3x. And I can't factor anything there, so that's times, and I'm going to have 2y minus 3x in parentheses, because I'm taking a monomial, x squared, times a binomial. Okay, we don't have to distribute. You want to leave things in factored form. On the bottom, I have 9x squared minus 4y squared, and I'm multiplying that by x cubed. Okay, this times that. Now, nothing on top factors, but this right here is a difference of two squares again. So you have to remember how to factor difference of two squares. I can square 3x to get 9x squared, so 3x goes in the first spot in both. I can square 2y to get 4y squared, so that goes in the second spot. One's a plus and one's a minus. So I've kind of replaced this with the factored form of it. All right, now what can cancel? And this is the canceling rules you need to know. First of all, with this and this, because it's multiplied by these other factors in parentheses, I can reduce that. These two are going to cancel with two of these and leave me with an x down there. Next thing I want you to notice are these two factors. This one and this one right here. They are opposites again. Notice the 2y was positive on top in that binomial factor. On the bottom it's negative. 3x negative on top. So we can cancel them. So I can cancel them out if I multiply by negative 1. So I'm going to, and you could do it on top or bottom, I'm going to multiply by negative 1 on top because they're opposite factors of each other. All right, so what are we left with? On top, these canceled out, so I'm left with negative 1. On the bottom, what do I have left? I have this factor of 3x plus 2y in parentheses, and I still have that x after we reduce the x squared over the x cubed on the bottom. So it's times x on the bottom. And you could put that x in front of the 3x plus 2y binomial factor or behind it. But basically, that is your answer right there. Or like I said, the x could be out in front there on the bottom. And I would just leave it. I wouldn't distribute the x back through. I would just leave it in factored form. And that's the lesson.